Okay, welcome back everyone. It's day 3 of Programming Basics. Today we'll be going over loops. Our assignments will be the loop-de-loop challenge, algo level 4 and 5, and operators 2. And then in the PM lecture, we'll be going over how to write functions. We went over this a little bit yesterday, but we'll do the official lesson today, and parameters. And lastly, we'll be doing the assignments return, debug, and parameters. And the end of the day challenge will be parameters. And the homework for tomorrow will be to read up and through belt tips and strategies. So let's go ahead and get started here. Watch this video on your own time. I'm going to explain in my own words how to understand a for loop. So for loop is used for when we want to count through some numbers and make the machine do it instead of us do it manually. So that means instead of console logging 0, console logging 1, 2, 3, and so forth, we want to give the machine some numbers to count through and have the program or the function that we write to console log a list of those numbers. So here we have our first view of a for loop. And so I'm going to write this for loop on the blackboard, and then I'm going to explain how to T-diagram, how to read it. So let me go ahead and copy this over. Okay. And here we are. So we have 4, and then we say var num equals 0. We say, well, num is less than or equal to 5. Num plus plus. Actually, let me rewrite this. Let's start from the top here. Every for loop needs that keyword for. And by the way that we're writing this for loop now is going to change in the future. We're just using terminology we're already familiar with. And as we get better at JavaScript, we'll have to polish some of these edges. Num is less than or equal to 5. We say num plus plus. And then here's the do something section. So we're going to console log num. Okay. So here is, I'm going to write our console section here. This is our special console area. And our T-diagram I will write here. So the way to read a for loop, the way to write a for loop is in these steps. First, we recognize, okay, there's a for loop. So we need to have a list of 4 steps. The first step is to read this. So I'll write here var and val for value, var and value. And we recognize this first variable is the number, it says num and 0. So we'll write here num. And then we have the value for 0. The next step is to read the part that is separated by the semicolon. So I'll highlight these semicolons here. This is step 1. This is step 2. Now we check, is num less than or equal to 5? Right now, num is 0. If num is less than or equal to 5, if this is true, then we enter in the do something section. We enter in here. And now we enter step 3. Step 3 says to console log num. So we'll do that. We'll go ahead and print to the console num, which right now is 0. So our first print is 0. Then we go to step 4, which is over here. It says num plus plus, and that means to increase num by 1.
Why is the program skipping num plus plus and going to console first?
That's just the way it does it. So I'm just giving you the order so that you can recognize the order. It would seem intuitive, right, to go 1, 2, 3, 4 in the bottom, but it really is this way. 1, then 2, and then you enter. As long as this is true. If this is true here, let me write a commentary here. Is it true? Then enter. Okay, so far this is true. So we have entered and we console logged, so we've done step 3. Let me write here also do something. And so now we go to step 4. We increase num by 1. So now the new value of num is 1. Once we've reached step 4, the new step 1, let me see here if I can make this. Yeah. The new step 1, well, it goes always back to step 2. Okay. This becomes the new step 2. And then this becomes the new step 3. Okay. So it goes like this. The first time you read it, step 1, then step 2, then you enter step 3, and then you increase. Once you increase it, then you go 1, enter 2, 3, 1, 2, 3. You ignore this value that we've originally given it because every time we increase it, we check to see here what's the new value that we've given it in our T diagram. Okay. I know it seems a bit awkward and confusing at first, but you'll get the hang of it and it'll be second nature in no time. So now that we've increased it by 1, we go back to our new step 1 and we check, is num less than or equal to 5? Right now, num is 1. So it is less than, or it's less than 5. So then we'll go ahead and go into our new step 2, which is console log num. Num right now is 1. So we'll go ahead and console log that. This is our console again. Okay. We just label it console. Okay. So we've increased it to 1. We've console logged it. And then so we go back to our new step 3. We increase it again. All right. So we'll do that. New value is 2. We add 1 to 2. So now our num is 2. Then we go back to 1. Is num less than or equal to 5? Yes, because num is 2, it's less than 5. So then we enter step 2, console log num. Okay, we've done it. Back to step 3. Increase num again. 3. Then we go back to step 1 here. Is num less than or equal to 5? Yes. Because num is 3, 3 is less than or equal to 5, so then we'll console log it. Console log num. After we do 2, and we go back to 3, and we increase it again. All right, so let's go down to this line here. 4, our num is now 4. Is num with the value of 4 less than or equal to 5? Yes, it's true. So then we enter in our new step 2, console log num, console log 4. Okay, now we'll increase num again, because we're now at our step 3. Once we finish this, we check it again. Is num less than or equal to 5? Yes, because 5 is equal to 5. So now we've reached the equal sign check. So we're getting close. So then we enter our do something section and we console log num, which is 5. And then we go to step 3 again. We increase num again. So now num is 6. Num is 6 now. So then we go back to our yellow step 1 here. And it says, is num less than or equal to 5? No, it's no longer less than or equal to 5. So then we're done. Once this is no longer true, then we do not enter. If it's not true, then we don't enter. And that's the steps that we need to read a for loop. Okay, I'm going to do a quick poll to make sure we're understanding this concept. Oh, my poll's not showing. Okay, so I'm
Hey,
going.
just real fast on the Algo app. Somebody correct me if I'm wrong, but I'm pretty sure for the console it has us put commas in between each of those. Is that not the correct way to do it on the console log?
So on a normal console, on a normal console log, it would not put commas unless you
Okay.
direct it to put commas. The reason they're having you put commas in the Algo app is because there's only one area, and without the commas, it'll interpret it as one giant number. But for us seeing the console, we'll see the difference between each number on a new line. And we
Gotcha.
we
Okay.
can check this on the Trace app as well. Okay. So This will be on the video. I'm going to go erase this screen. I may have to do this process a couple more times. But this is the way we go through a for loop. Does anyone have any specific questions about what I did here? Okay. Remember, it's 1, 2, 3, enter, then 4. Then it becomes 1, 2, 3, 1, 2, 3, 1, 2, 3. And we're always checking the value that we've logged in our T diagram.
Is it possible to explain it like one more time?
Sure, sure. Okay, let me clear this out. Let me do a quick poll to make sure I'm doing the pulse check here. Okay, we'll do another version. And then we'll run it on trace. Okay, so we have our for loop. Every for loop needs to start with this keyword for. That's how we know we're entering a for loop. Then we declare a variable. This is our starting point. Oh, I already messed it up. It's like a pen, I can't erase it. For var, that's our keyword for variable, num equals 0. Then we separate it by a semicolon. Each section in the for loop is separated by a semicolon. So then we say, this is our check. While num is less than or equal to 5. Oh, let me make this red. Then we say num plus plus. Okay, this is the place where we do all our checks. We start the do something section by the curly brackets. And then we say inside here, console.log num. Okay, let's write our T diagram. On the left is our variables. On the right is our values. And let's write the console section here. Okay, so step 1. We read it from left to right. So we're reading for var num equals 0. This is step 1. This here. So go ahead and write this in our T diagram. Num is 0. Simple enough, right? Then we enter section 2. Okay, left, right, then num, if it's less than or equal to 5, then if this is true, enter. Okay, and by enter, I mean enter this section, the do something section. Okay. So again, I'll write this note. If true, enter the do something section. Okay, right now it is true. So then we enter here, and this is our step 3 now. We now want to console log num. Num is 0. So we enter our console, this little box here. This is our special screen. And we say 0. Then we enter step 4. 4 is here. So then we increase num. Num plus plus means increase by 1. So then we'll do that. We'll go to our T diagram and we'll increase it by 1. So now this is the new value of num here, 1. Once we've reached step 4, by going through the for loop the first time, then we have a new way of reading through this for loop. This becomes the new step 1. This becomes the new step 2. And this becomes the new step 3. Okay, so let's go through our step 1. Is num less than or equal to 5? Yes, because it's 1 right now. So then we enter step 2, console log num. All right, num is 1, so we'll go ahead and console log it. We go to step 3, we increase num by 1. Okay, so then it becomes 2. We go back to 1. Is num less than or equal to 5? Yes, because num is 2, it's less than 5. So then we enter our new step 2, console log num. Okay, that means we want to check what num is. Let's console log it. Go to step 3. Increase num again by 1. All right, so we'll increase it to 3. And then we check again, step 1. Is num less than or equal to 5? Yep, because it's 3. So we'll go ahead and enter section 2, console log it. Then after 2, we go to 3 again, num plus plus. All right, so that means we increase it again, goes to 4. Once we finish 3, then we go back to 1 and we check again. Is num less than or equal to 5? Yes, it's less than 5 because it's 4. We'll console log it again here. Then once we finish step 2, we increase it again. Num plus plus. All right, it's 5 now. Is num less than or equal to 5? Yes, it's equal to 5. So then we'll enter section 2, because if it's true, we enter the do something section, console log num. All right, so we'll do that now. Console log num. Once we finish step 2, we go back to step 3. Anytime we do 2, we go to 3. And it says increase num again. All right, so we'll increase it to 6. Is num less than or equal to 5? Is 6 less than or equal to 5? No. And if this is not true, if this is no longer true, we've completely finished everything. So now we're done. Okay, we'll have more practice with this as we go along. This is the way we go through it. We go 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. Okay, our eyes are just going to have to get used to reading it that way. All right, let's take a new poll here. Okay. So again, we'll have more practice with this. We'll have plenty of practice with this in the Algo app. And I'll go over this as many times as we need to understand. But we read it from left to right. We check var num equals 0. Okay, so right now num is 0. And then we enter the for loop. I'll do a different for loop, so we're not just, beating you over the head with the same one. Okay. So then let's go over some different ways that we can write the for loop. If var index equals 2, let's T-diagram this. No, it doesn't want to write it. Okay, var index equals 2. And if we say index equals index plus 1, at what point will what number will it be right now? If we say index, which is 2, equals itself plus 1. Yep, I see some 3s. 3. Yes, if index equals 2 plus 1, then the new value of index is going to be 3. And then if we say index plus plus, that's the same as saying increase by 1. So if it's at 3 on this line, by the time we get to this line, index is now going to equal 4. So by the end of the third line, index is now going to equal 4. Okay, let's do the same thing here. We start with 5. Then we say counter equals counter minus 1. Let me write this here. We can all do this from scratch. Okay. Counter right now is 5. And if we say counter equals itself minus 1, then the new value is 4. Counter is 4. And if we say counter minus minus, that means decrease by 1. So now the new value is 3. And then it says counter times equals 6. So what do we think this will be? What's the value for this? What is times equals?
18.
Right? Okay, so it's saying multiply itself by 6. So 3 times 6 is 18. That's correct. And then it says counter. Divide equals 2. So divide counter now by 2. So what's 18 divided by 2?
9.
And that's our final value. So times equals means multiplies itself by the number on the right. that division equals sign means divides itself by the number on the right. Minus minus means -1, which is essentially the same as this here. Counter -1. Let's try to switch this up a
Could
little bit.
sorry, could you write counter, let's say, times 3 for the first line, but now line 11?
On line 11,
Yeah,
so you want it to be counter equals counter times 3.
yeah. Could you write like,
What it would be if it was this? Sure.
yeah.
Okay, let's switch up a few more as well. Okay, we'll leave this counter minus minus. And we'll say times equals 9. How about that? And then we'll divide it by 3. We'll see what number this comes out to be. It may not be an even number, maybe like a decimal. Okay, so we have counter. We start with 5. Then we say counter equals counter times 3. So what is counter right now? 5. So counter times 3. 3 times 5, 15. Then we say counter minus minus. So whatever counter is last, it's 15. Then we decrease it by 1. So the new value is 14. Then we say counter times equals 9. So what's 14 times 9? Oh, I can't do math. Let's see.
126.
126. Okay. So now we have 126, and then we say counter, which is now 126, divide equals 3. Who's got a counter?
42.
42. Are we following along? All right. See, 1 thumb up, 2 thumbs up, 3, 4, 5. Oh, lots of thumbs. Cool. All right. So let's continue. The main point is times equals means multiply by this number. Divide equals means divide by this number. Minus minus means subtract by 1. And we can also subtract by a specific number if we say counter equals counter minus. And then we say whatever number on the right. We can subtract it by 2, subtract it by 3, so on and so forth.
So if you use counter, you essentially want to be specific with what you want to do.
Right, you can make it equal 1. There's no rule that says you can't, but the shorter way would be to say minus minus.
Gotcha.
Okay, so now let's do this for loop. Let's do it the way we did it the first one. So I'll go ahead and write it here for my own notes. And then I'll do another Blackboard. Okay, so we have the for loop, which says for bar num equals 10. And while num is greater than 2, num equals num minus 1. So this is our do something section. And then while we're in here, we want to console log num is currently and then we say num. Anything we enter in the console log that has quotations around it is a string. And if we put a comma after the string, then we can specify a specific variable. If it doesn't have quotations around it, it's looking for a variable name. Okay, so let's go ahead and write our T diagram. Var val. Okay, this section here will be our console. Okay, so number one, step one. We start here. Var num equals 10. So then we say num equals 10. And then we enter our step two. While num is greater than 2. Num is greater than 2 because it's 10 right now. So we enter our step 3. Okay, the whole thing is our step 3 here. Whatever's in the do something section is all of step 3. So it wants us now to console log the string num is currently plus the value of num. Okay, I don't have space to write num is currently. Maybe I do. Num is currently, and then what's num? 10. Then we increase to step 4. And it says num equals itself minus 1. Okay, so what's num right now? It's 10. So 10 minus 1 is 9. So then we go to our new step 1. This area here. While num is greater than 2. Okay, 9 is greater than 2. We enter console log. So then we say num is currently and then we say it's 9. And so then once we finish our step 2 here, then we go to step 3. We decrease by 1. And you can probably already tell that I'm running out of space and that the pattern is going to console log 8, num is currently 8, num is currently 7. And we are going to then fast forward the process here. 7, 6, 5, 4. It's going to console log 7, 6, 5, 4. And then we're getting close to 3. So we'll say, okay, we're going to get to 3. That's going to qualify while num is greater than 2. All right. So then we enter this section. Num is currently, so we're going to write num is currently this stuff. Num is currently 3. Then we're going to decrease it by 1 again. So then we're going to enter into 2. And is 2 greater than 2? No, 2 is equal to 2. It's not greater than itself. 2 is not greater than 2. So we exit this for loop. We finished. As soon as this is no longer true, this middle section here, as soon as this is no longer true, we've finished completely. Okay. So our variable, this one that we've declared here, the one that we're decreasing every time, we decrease it to a point where we can no longer qualify this check here. Once that no longer qualifies, we no longer enter the do something section, and we exit the for loop completely. Okay, doesn't want to write for me anymore. This is the way we've started the for loop from 10, and now we're decreasing. So we can increase in a for loop, and we can also decrease in a for loop. All right, let's do another poll check. Any questions about this? It's just going to get more familiar with practice. So, let's continue here. We have our loop-de-loop challenge. We want to create our file called last name and then loop-de-loop. And here are the directions. A local fitness coach and a mechanical engineer are building an LOT device that pops up a piece of candy every time a runner reaches 2 miles on a treadmill, but stops giving candy out at mile 6. So you're building a machine that when someone's running on a treadmill, every 2 miles, it pops out a piece of candy. When they reach mile 6, it will stop giving candy. We're tasked with building a loop functionality to know when to give a piece of candy and when to stop. Using comments in your VS Code to answer the following questions. How do we know we need a loop here? What's the starting point of the loop? When should the loop stop? How will the loop know when to stop? What's incrementing for each iteration of the loop? And what variables do we need? Okay, it's a simple for loop that we have to create, one that we've already created, except now every 2 miles we're doing something. Okay, so that's our first practice challenge.
For the extra feature part, how would we add that in there?
Now the extra feature says create a new loop where the runner only gets a piece of candy every 2 miles, and if they were going faster than 5.5 miles per hour. So this is a new loop, so we have to create something new. And this and here, we're going to answer in the next lecture section here. Okay.
I have a question with the loop-de-loop. Is it saying to give out a piece of candy? Obviously, it's saying give out a piece of candy every 2 miles. Is it saying as soon as you hit mile 6, no more candy is given? Or once you hit mile 6, you get a piece of candy, but then after that, no more candy?
So at mile 6, you get a piece of candy, but then after that, you get no more candy.
So at mile 6, okay, got you.
Yeah.
Okay.
Yep. Okay, so I'll give a hint for this one here, okay? And here's my hint. All programs everywhere are a combination of if statements and for loops. If statements and for loops, they go together now. Okay, we're going to now combine if statements and for loops. So think, all right, we have to create a variable somewhere that accounts for the speed, right? And then we're going to check if it's reaching this speed, if it's faster than 5.5 miles an hour, then you enter the loop. Okay, if I give any more hint than that, I'm doing it for you. Okay. And whenever we read a problem, like a key, like a, how do I say it? I just lost the word. A problem description like this, right? A paragraph. We're going to find the keywords on how to build our program with keywords we find in the problem description, if they were going faster than 5.5 miles an hour. Okay. So an if statement has to be added in addition and plus a loop, a for loop. Okay. So think, whenever we see the keyword if, that's going to be key to solving or creating the algorithm or the problem that we're building. Okay. Now we're going to go over operators. And let's just get a quick overview of what we're going to do here. All right, so the first operator is the modulo operator. Okay, so what this operator is it's checking. Let me write it here. It's checking here 10. Let's just do an example, okay? This is the modulo operator. It looks like a percentage sign. How many times does 2 go into 10? 5 times, right? And now, after it's divided itself into 10, is there anything left over? No. So 10 modulo 2 is equal to 0. Is this statement true? Yes. So then we're using this to determine that there is no remainder, divides into it evenly. Okay. How about this here? 9 modulo 2. Is it equal to 0? Is this statement true? No. Right? Because 9 modulo 2 is going to be, it's going to have a remainder of 1. Okay? If it were a true statement, it would say 9 modulo 2 is equal to 1. And so this is a way that we can check the remainder of something and to see if we can use it for multiple purposes. We can check to see if something is even, if something is odd. Because if for example, we say we have a number x, right? We don't know what number it is. We're just giving a number x. It could be any range number. If we say x modulo 2 is equal to 0, what do we know about x if this is true?
X is even.
Even, exactly. Because 2 will divide into any even number evenly. Okay, now let's do another one here. If we say x modulo 2 is not equal to 0. What do we know about this now?
It's odd.
Yes, this is odd. If any number modulo 2 is not equal to 0, then we know it's an odd number because it won't divide into it evenly. The remainder won't be 0. Okay, let's rewrite it again. So
The remainder would have to be 1 for it to be odd.
yes. So if x modulo 2 is equal to 1, what do we know about x now?
Odd.
Right. And we know this is an odd number. And that's how we'll use modulo operator in general. If we say x modulo 3 is equal to 0, what do we know about x now? It's kind of a trick question. It's so
It's
easy.
It's
divisible by
divisible by
3.
3.
Yeah,
It's-
it's a multiple of 3.
Also, I apologize a second ago for how quick I jumped on that, and I was incorrect. Not equal to 0 also works because we're doing modulos, not division. I forgot. Sorry.
Yeah, it's kind of like
Mea
division
culpa.
because we're checking the remainder after we
Yeah.
divide it.
Yep.
Yeah, no worries. Right? It's okay to get excited. So let's go ahead and continue. So that's what this whole lesson will explain here. Here's a new operation called modulo. Modulo is a magic Lego piece. Once you figure out when it's what it's useful, modulo is a magic Lego piece. Once you figure out when it's useful to use, it's a powerful tool. Here's a puzzle. How would you determine if a number is odd or even? Okay. The answer is if the number is divisible by 2, it's even. All right. Okay, but how do you tell the computer that? If you divide the number by 2 and there is no remainder, or if there's nothing left over. So that's what we're checking with the modulo. When would you use this? If you ever needed to identify something that is odd or even, it comes in handy. If you ever needed to do something with the remainder, like putting leftover pennies in a digital piggy bank, modulo comes in handy. So in this case, we have our first variable, number of pennies, 12. And then we say var number of people equals 5. So the remaining pennies, we can create a new variable that says the number of pennies modulo number of people. So this variable now is going to equal 2. So we can also do stuff with that remainder as well. We can not only use it for a check for odd and even, but we can take that remainder and apply it to something, apply it to a variable. Then we can say, by this number of 2, add it to our piggy bank, another variable that would hold our piggy bank, and then we can add it to that piggy bank by that modulo number.
Quick question. What would be like a good use of the modulo like in a real life programming situation?
Like this here. If you want to take the remainder of something and add it to, like, let's say you're doing a banking app.
Yeah.
And you want to take that remainder and add it to, whatever leftover.
Oh, okay. That's a good example. Okay.
Yeah. Or if you want to check to see if something is even or odd, that's always a good application of something as well.
Okay.
So, like, technically, could we have built that last for loop using the modulo since it's 2, 4, 6?
Which for loop? I'm already losing track?
The loop-de-loop.
Well, I want to give you the answer, but I want you to experiment also. So I'll just leave it to you to experiment with that. Okay, we're now computer scientists. That means we're going to try to find the answer by experimentation. But I could give you a short answer, and that may explain it for you already. I don't want to do that. I want to have the fun, leave some fun for you guys. If you can't get it to work, maybe I'll work with you. Well, find me if you can't get that to work. All right. So here we also have a couple of the inbuilt JavaScript functions math from the math library. Okay. So it's math.round. All right. We know that, or we're going to find out if we don't know. When we have a number 1, 2, 3, 4, 5, 6, 7, 8, 9. If we have a number that's at 5, we round it upwards. Anything below 5, we round downwards. Okay. So if we say math.round 2.5, it goes up to the nearest whole number, which is 3, because 5 rounds upward. Okay. Math.round 2.4 is going to be 2. It's going to round down to the nearest whole number. 0.4 will go down to 0.0, and it will be 2.0, which is the same as 2. If we say math.round negative 2.9, it will round to the nearest whole number, which is negative 3. And if we do math.round negative 2.1, it will round to negative 2. If it's a negative number, it's still going to the nearest whole number, but it's going in the opposite direction, right? If we say math.round negative 2.9, it's going to negative 3. It's going downward. Negative 2.1 is going upward to 2. Okay, so let's get a pulse check. Actually, I didn't get one for the modulo symbol, so let's do the modulo symbol one more time here. How well we understand the modulo sign. To be honest, the first time I had the modulo sign explained to me, I didn't get it. I wish I got it, but I got it for a second, and then it escaped me. I didn't really understand it.
I get the modulo. I guess I just don't get how to apply it.
Okay, that's what the assignments are for. We'll definitely have you apply the modulo symbol. And the more you get practice on the Algo app, the more familiar you'll be with it. Okay. What I want to do is continue here. Then we have math.floor. So math.floor is going to bring any number that we have down to the floor. So for example, if we have, I'll just write it from top to bottom, 9, 8, 7, 6. Ooh, that's an ugly 6, 5, 6, 5, 4, 3, 2, 1. any number that's a decimal point. So we'll say 2.9. It'll bring it down all the way to 2.0. That's for any number on this list. It's going to bring it down to the floor. So imagine 2.9 math.floor. It's going downward. Down to the floor, 0. So math.floor 2.5 is 2. Math.floor 2.4 is 2. And remember, when we go negative, we're still going down, right? -3 is less than -2.9, so that's the nearest whole number. -2.9 is going down to -3. -2.1 is still going down to 3. It's going down no matter if it's negative or positive. So -2.7. If I say math.floor, this one, what's the number going to be? -3, right? If I say -9.9 math.floor, this one, what's the number going to be? Right, -10. All right. On the contrary, math.ceil is going to push everything upward to the ceiling. So 2.5 goes to 3. 2.4 to 3. -2.9 to 2. -2.1 to 2. It's going up now to the ceiling. So whatever value, if you have to be aware if it's negative or positive. If it's positive, they're still going upward. But you have to think, if it's a negative number, -2.9 is going to go upward to the ceiling to 2, because 2 is more of a value than -2.9, right? You'd rather be -2 in debt than -2.9. So it's going to go upward to -2. And lastly, we have math.trunk. What trunk does, it's like it truncates. Think about it's cutting off the trunk of a tree, right? So 2.5, we're going to cut off the end here. It's 2. 2.4, 2. -2.9, -2. -2.1, just cut off the end. It's -2. All right, I'm going to do another poll here. How well we understand the math libraries for math floor, math ceil, math round, and math trunk. Cool. We don't need to read over this. I already explained it then. So that ends the time for today's lecture. I'll go over this optional assignment here, and I'll explain it. So MVP, as a user, I need to know how many pieces of cake I will have left over if I divide out my cake, which has 12 pieces for 5 people to eat. Okay. So think, what sign would we need to use to do this? And feature 1 is, as the designated cake slicer and distributor at our office birthday parties, I want a function called how much leftover cake that passes 2 variables, number of pieces and number of people, into it and figures out the remaining pieces of cake. Now feature 2 says, building off feature 1, I want a console log to display no leftovers for you if there aren't any leftovers. You have some leftovers if there are 2 pieces of cake or less, where you have leftovers to share if there are 3 to 5 pieces of cake left over. And hold another party if there are more than 5 pieces of cake left over. So based on these different situations, and what's the keyword that we need to note in order to build this? It's right there. If. So we write some if statements. We can also write else if and else statements as well. Cool. Do we have any questions about this one? All right. So let's go ahead and continue with our work. I'm going to go ahead and create the breakout rooms. Stop the recording.